Hello and welcome to the Big Tech Day 2021. It's nice to see you all here in the room in person after seeing each other for 1 year only remotely. Now we're finally back in Munich in the Western Grand. Also a warm welcome to everyone who joins us remotely via Zoom or on YouTube. A warm welcome to you. I'm David. I'm software consultant at TNG. And I will lead you through this talk. For all those who are here the first time, what is the Big Tech Day? The Big Tech Day is a conference with topics from science and technology, especially IT, and is hosted by TNG. The program for today you can find on bigtechday.com. And all those who are remotely, you can find all Zoom links and YouTube links, as well as all links to the Slack channels there. If you want the best conference experience, I would recommend you to also sign up for our Slack workspace that we created just for today, so that you can ask questions, connect to all the other people on the conference remotely as well as on premise. And yeah, you can access this workspace also via bigtechday.com. If you have questions, I would propose for this talk that we ask the questions in our Slack channel so that we have it on one place. And last but not least, I would ask you to put your phones on silent mode. Today's talk is about best practices for managing large infrastructure. Thank you, Lukas and Thilo, that you're there today. I have the honor to work with you every day, and I will briefly introduce you. Lukas, you have a passion for professional software development for more than 10 years already. You studied informatics and worked as a web developer before you joined TNG. At TNG, you became a cloud native. You were working mostly in the cloud native area with focus on containerization and Kubernetes, and are an expert in DevOps questions. One sentence that I found on your LinkedIn profile describes you pretty well, I think. First, I thought one can achieve everything with web technology. Now I know it's nothing without container runtimes. Thilo, you studied computer science and worked for more than 10 years in the automation and configuration of Linux-based open source software. Then you joined Allianz, and today you're leading a team with 10 developers. We are developing workflows to provide standardized and managed software for more than hundreds of development teams at Allianz. And now I do not want to occupy the stage anymore, but give it to you. I'm very excited.
Many thanks, David, for the introduction. Many thanks for giving us the opportunity to speak here about managing large infrastructure. Let's look at the agenda that we prepared. And as you can see, we have a lot of questions, but don't worry, we have also some answers for you. So let's have a look. Say again, we will look at what is our environment, what is our challenge that we faced, and introduce our environment. Then we will talk about how we manage large infrastructure. And also, how do we manage arbitrary configurations? Then we will have a look at how do users get their service instances. We'll talk about how much we did all suffer during this process. And finally, we will come to the benefits and the recommendations that we want to give you. And last but not least, we will answer the question if we would do it again. All right, so best practices for managing large infrastructure. the standard approach is buy lots of computers, contract a big company to set up your data center and manage it, ask them to install a virtualization platform. Then you can create a virtual machine, install your application, configure it. After that, you clone it 1,000 times, and that's it. So now we're open to questions. Thanks for attending the session. But that was the past. And even in the past, it wasn't that good of an idea.
Yeah, right. So that was the past. And the past led us to those questions. So these are typical questions for operators. So I myself asked those questions to operators. Let's start with the first one. It's how do we manage all these instances? Which one of those are already upgraded? Is the latest security fix applied everywhere? Can we get something smaller than a virtual machine? And last but not least, it's not a question. It's like just a statement. Snowflakes. I like snowflakes, but only during wintertime. So Thilo, what are snowflakes, and why don't we like snowflakes?
Yeah. Why we don't like snowflakes. So snowflakes, it's something we have seen in the past. And it is basically some software, some application, some service that got set up by a team or an individual developer. And it was, in the beginning, very well maintained, updated regularly, customized to the needs of the team. But then over time, maybe this person who initially set it up joined another team, left the company, and over time, all the knowledge about those applications or services is lost in time, and the team struggled to do any change to these applications or services. And so what we have seen is that there is many instances floating around that are kind of similar, but not exactly. So they are still individual, like snowflakes. They have a little bit of customization, maybe a plugin installed, but over time, totally outdated, hard to maintain, and hard to manage. And that is something we really want to avoid for our service. So what do we actually want to achieve? What is our environment? What was our challenge? And yeah, we want to provide a similar application instances to different users or teams. And in our environment, what we currently have is 6 different applications. We have deployed them in 9 different locations in on-premise data centers, but also many cloud regions. We have more than 100 teams using these applications. And in total, we have more than 700 instances. And this whole service is still growing. So every month, every year, we get more and more teams using it and more instances get deployed. And the most important part is, while we are still scaling up, fortunately, the support tickets don't scale in a linear way. So we can see this, especially that the team that is developing this infrastructure and maintaining it and operating it and supporting it is still more or less same size over the last couple of years. And we are still able to manage this in a rather small team. Okay, so what do we need to take care of? And there's 2 important parts. First of all, we want to reduce the manual interaction with our users. So what we want is a CRUD via self-service, meaning create, read, update, delete. So users can just go to a self-service application and order their application instance without we also want to enable the customers to customize their applications. We don't want to just give them a pre-configured application that cannot be changed anymore. We want to enable as much as possible custom configurations that is in the hands of the users. And the second important part is we want to reduce efforts for us and for our users. And one thing is that we provide a standardized set of tools. So meaning that no matter in which team you go, you will find the same kind of tools, maybe customized to some degree, but still the same overall approach. And that reduces for the teams the onboarding time for the developers. For example, if a developer switches from one team to another and you find the same set of tools or applications, it will be super fast for him to get onboarded. Then this approach should also reduce the maintenance time for the individual teams. So as we provide a standardized tool set and take over some parts of the maintenance, like updating instances, it will reduce the efforts for the individual teams. And last but not least, it will increase security because we can put the time into properly set up the services, make sure that there's a proper baseline that covers essential security aspects. And we will also make sure to apply regular updates to keep the application secure. All right. So that's our environment, our setting, the challenge we faced. And now let's see, how do we manage large infrastructure?
Yeah, thanks. So I will take it over again, and we have prepared another set of typical questions for operators. I raised myself as well. So as a motivation again for infrastructure, managing large infrastructure, how many instances do we have running? In which data centers are they running? Which versions are they on? Can this instance be removed? Does anyone know? Is it still used? Do these instances differ in their configurations, or are they just the same? How many resources did we assign to them? And how many more can we actually deploy until we have no space left? So Thilo, from your experience as operator, what are the typical answers?
Yeah, it should be easy for me. I have many years of experience in operating systems. So let's have a look into the cluster. Oh, I don't know really. Okay, let's ask. Yeah, I guess this one was created by the one who left the company last year. Oh, please don't touch this one. Not sure if it will start up properly if we restart the machine now. Okay, let's turn this one off and wait a month. If no one complains, then we can finally delete it. And I need to admit the last one just happened a couple of weeks ago. So we really had some legacy system around where no one knew if it was still in use. We had kind of the feeling looking at the logs that it was not really used, but we were not sure. And yeah, the guy who originally set it up was no longer with the company. Sounds familiar. And so we had really to do this approach.
Yeah,
but I think we can do better.
Right. So from my developer's perspective, my idea is like, why don't we have a list? It cannot be that complicated. We can automate that. I want all those services to be identical. They should only differ on purpose. We need to know who did what, when, and why. And honestly, have you ever heard about version control? So that's also kind of the motivation for on an infrastructure level. And we don't only ask questions and complain, but we also provide solutions here in the talk. So the first one we are going to talk about is infrastructure as code. So the idea is that we treat infrastructure as if it would be source code. Most likely declarative code, most likely stored in version control. Then we will always recommend to introduce an inventory which contains all the instances and their parameters. And in order to make sure that this inventory matches the actual instances, we need to have the last point, the automation. We need to implement an automation which ensures that the inventory matches the actual instances. So talking about instances, actual instances, how does such an instance look like? Most likely it's not bare metal. It's not possible to create a new machine with code, not at least not for us. Maybe it's possible in the innovation hacking team. For us, it's not possible. So it's most likely virtual machines. But also virtual machines are quite heavy. So the idea is, can we use containers? What about containers? They are lightweight virtualizations. They provide some isolation between each other, and they share operating system services. So they are quite fast and flexible. Commonly known Docker, for sure. We are not going to talk about Docker too much, but it's one famous way how to containerize something. So this leads us to our first excursion here about containers. The first question we will answer is, how can we create a container image? Second, Thilo.
How can we run a container?
And last one is, how can we orchestrate containers? So let's run right there. So how can we create a container image? This is just a quick sample. It's a Docker file. We say we derive from something. We derive from Alpine. This is a quite lightweight, small image. Then we copy some files there as the application. Maybe we need to install something during the image build process. We can define environment variables, for example, default stage, which is development and can be changed to production in production. And we define what should be executed when we start the container. And last but not least, we define also some metadata. So which port is this application providing some service? So we did this also in the past, and similar to the issues we had with the uncontrolled instances of virtual machines, for example, it can lead to the same thing here. So if we answer the question, how can we run container on a virtual machine, then we can simply say, let's execute Docker run, publish 3000 image name, and that's it. And we have one container running. And yeah, we can automate this for sure, but it most likely does not scale properly. It most likely escalates. So Thilo, the question is, how can we orchestrate lots of containers?
Yeah, so here we come to the topic of container runtimes. And there's many different runtimes, but in our company, we focused on Kubernetes-based runtimes. And initially, we started off with OpenShift. That's a Kubernetes-based environment from Red Hat with some additional features on top of Kubernetes. And later we moved on to Kubernetes, native Kubernetes from the cloud providers AWS and Azure. There's many more, but that is our specific environment. And the main advantage why we want to use a container runtime is that we can have our infrastructure defined in code. But there's many more things that Kubernetes and the container runtime provides us. So how can we benefit from using Kubernetes? Yeah, as I mentioned, it implements a declarative configuration interface, and this enables us to have infrastructure as code also for container instances. Then Kubernetes combines virtual machines to a cluster. So we are not limited to single virtual machines or even bare metal and need to add our own cluster management. Kubernetes does that for us, and the modern setups of Kubernetes usually come with an automated on-demand scaling, so we don't even have to care about scaling up or scaling down the cluster. Then Kubernetes enables a lot of things that we need for our use case. First of all, we have application deployments. This is what we need to create dedicated instances for our users. Then it has routing, so we can easily expose HTTP endpoints for our services. and make it available to the users. It has built-in health checks or a framework for health checks that we can use to then have a basic self-healing in the service. So Kubernetes automatically restarts containers that have a failed health check. And in many times, this already helps to keep a service running, and is a basic thing of self-healing. Okay, so how do we do infrastructure as code with containers?
Yeah, right. So let's jump in here again. So provide a container image, very first step. Then we need to use the container image. So we define all the Kubernetes resources, such as deployment, ingress for routing, and so on. And also because we want infrastructure as code, we somehow need to control how we define those Kubernetes resources. And the next point is here, manage those resources with something like Helm. So we prefer Helm at the moment. It's quite a nice tool to define all those Kubernetes resources. And one of the most important things here is about how we treat the containers. So we expect the containers to be deleted and recreated anytime. At the beginning, when coming from virtual machines, when using virtual machines, one could think like containers are the same as virtual machines. So we just start a container and we keep it running. We keep the container running and we store some things in the container and we restart it maybe, but we will never delete it and recreate it because we configured stuff in the container. And that should never be the case. So we need to separate persistent data from the container as well and prepare that a container can be recreated anytime. So in order to scale, how does it scale? How do we manage large infrastructure? So the first one is, again, containerize as much as possible. So as a service provider, you always need to think, is it feasible? Can we containerize it? Maybe it's better not to containerize it. Maybe it's better to use something else, a cloud service or a virtual machine actually, but containerize as much as possible. Next one, T.
Yeah, introduce infrastructure as code with proper automation. And here we have two aspects. So first of all, we want to use infrastructure as code to manage our Kubernetes clusters. And in our case, we use Terraform for it. Common tool, especially if you're targeting cloud environments. And the second part is that we also want to manage all our service instances with infrastructure as code. And here we use Helm to create and update the individual instances.
Next step is we need to prepare for the Kubernetes for scale. So we need to ensure to have enough physical resources. Well, what should not happen is that you have auto-scaling Kubernetes instances, but you're running out of resources, physical resources. So either make sure you have enough, but not too much, because then it's getting too expensive, or make use of a public cloud provider who is like telling us to have enough resources and guarantees this. And last one.
Yeah, and finally, support more than one Kubernetes cluster. Think big, expand around the world. And this is basically what we did. So we started with a rather small instance on-premise in our own data center, and over time added more and more data centers, moved to the cloud, and added more and more cloud regions. And with infrastructure as code, you can really use the same code, the same automation that you used on-prem, and basically you just reuse it for other regions or cloud regions.
Okay, so wait, Thilo, did we answer all questions?
So let's have a look. I think we covered most of it, but let's see. There is one that we did not really answer so far. And this is, do these instances differ in their configuration? And we did not talk about configuration yet, but this we will cover in the next part. So how do we support arbitrary configurations?
Yeah, right. And we are just, for the fun of it, starting again with a set of questions for operators, part 2, or actually, yeah, it will never stop. So can we update the service? I mean, right now, what do you mean by we cannot roll back? Can we get an exact same copy for as a test instance? And also kind of a question is like, it worked on develop. Is there a difference between development and production? Can we migrate it to another data center? Who did this change? I don't get it. It worked last time. What's different? And I need an audit trail. No question about it. So Thilo, from your experience as operator, what are typical questions here?
No, again, the embarrassing part for me, but I guess we rather skip it this time.
Okay, well, let's give it. Let's start again with the developer's perspective. So why don't we have a list? It cannot be that complicated. We can automate that. I want all those services to be identical. They should only differ on, wait. Oh yeah, that's the same list as before. Yeah, and still, have you ever heard about version control? So it's the same. It's the same perspective from the developer point of view. It doesn't matter if it's infrastructure as code or configuration as code. So this is the next main topic we want to introduce here in order to manage large infrastructure. So we want to treat application, the configuration of the application as if it was code. And most likely declarative code, most likely stored in version control. In our setting, and what we recommend here is one repository per service or service stack, which contains all the configuration of all instances and their parameters. So to separate this here, it's not about the fact that the instance is created and has some physical resources or some virtual resources, but it's more about how is it actually configured? How does it look like? And also for this, we need to have an implementation of the automation, which ensures that the service can read it from version control, because most of the services, most of the applications we provide, they cannot read configuration from version control. And we need to ensure that the configuration, which is stored in the version control, is applied to the service and does match the service configuration. So let's recap, Thilo. What are those services, applications, what we are talking about?
Yeah, the services we provide are third-party applications, not implemented by us. The applications are from a pre-cloud era and anything else but cloud ready. So they are more intended to be installed on regular servers like virtual machines or even bare metal. And they are usually managed by ops people. So it's really like usually a manual thing that ops people install it on a system, what we mentioned initially, and then continue to manage it, but not intended to be run on a container runtime. So that is one of the challenges we faced.
Okay, so how can we provide configuration as code for any kind of application? So first is containerize it. It's the same with the infrastructure question. Then we need to implement a configuration as code interface and the automation. And we need to make the application stateless. We need to try hard. So the idea is get rid of persistent data as much as possible. So if we can say that the application does only, the container then does only contain the configuration, but nothing else, then we are in a quite good situation. So how does such a concept look like? The configuration as code concept here. So we store and read the configuration from a Git repository, for example. We apply the configuration, and then we use the application. But that's just a rough picture. So let's draw a picture here. So first, we have the container runtime. The container runtime needs to be created by something. So we have here an infrastructure repository, which contains the infrastructure as code implementation, for example, with Terraform or Helm. And this defines the container runtime. On the next level, this also defines which service instances are created. And those customized instances, they need to be defined somewhere as well. So we have another repository here. There we go. So we have the service itself with the application code and our configuration as code implementation. In our case, it's most likely Docker files, some default configuration, some shell scripting, and this provides the same functionality for all of those customized instances. And how are they customized? via some configuration. So the application configuration is the third repository here. It's actually not one, but one for each instance or instance stack. And it contains user-specific, typically that declarative configuration. And this is this provides the individual configuration for these customized instances. So if we now go inside such an instance and have a look into the application timeline, then it's maybe a little bit more clear what we are talking about. So this is just a rough picture of the application timeline. So at first, we start with the infrastructure. We need to create the deployment, the volumes, the container itself. Then at the moment when we start it, configuration as code kicks in. So we execute the entry point. Then first thing is we clone the customer settings. We clone the specific customized configuration. We prepare the application. So some things, some services require the application to be configured before we start the application, like putting some regular configurations files at some places. But also after we start the application itself, we need to wait until it's ready because some things can only be configured in the application itself. So we need to execute scripts again, which call the API in order to configure the application for things which can only be configured during runtime. And this leads us to the state where we are ready and the application can actually be accessed and used. Ideally, we can also reload the configuration online while the container is running, while the application is running. So we don't need to restart in order to apply configuration changes. Okay, so Thilo, is this everything?
Yeah, is this everything? Applications are configured now the same way. But what about their states? So some applications might store some states somewhere. So what do we do with that?
Yeah, right. So we also ask us this question, and this is what we come here to share with you. So how do we handle application states? So on the left-hand side, we see the state. It's either stateless, partial stateful, or fully stateful. So we actually have a state. And the question is, how does the configuration as code interface look like depending on the state? So let's go into this here. So first, we have the stateless approach. And there we can just say, like, we start the application and we configure everything from scratch. We can simply apply the configuration from scratch and everything will be configured just as we want it to be. So if you would come with a solution for an application which actually is used and stores data and wants to provide the data even after restart, reconfiguring, customers will not be happy, users will not be happy. They will complain that they need a state because that's the use case for some applications. So one application to be specific here is like a Jenkins application. If you say you put everything in code and you configure it, what about the history? Was it successful last time or not? You don't want to decide whether you want to get a new configuration or keep the state. So we can partially be stateful. And that's the second one here. So we merge the previous state, we keep it somewhere, and we merge it on top of the configured application after we configured it. And the last one is that we actually keep everything and we keep the previous state and then we just adjust the configuration. This can be seen something like a database. So one would always adjust the database, migrate a database, but not remove everything, create again a structure, and then merge all the previous values into the database. So for any service which typical or its main use case is to provide data, one would go with the third approach here. One way how we implemented it was we created everything with configuration as code, the whole configuration. Then we compared the configuration as code repository with the configuration of the application itself. And then we deleted all the additional objects, which are not part of the configuration anymore, or maybe they were not configured at any time. Okay, so much about this part. But Thilo, how much No, that's not yet. So the question is, how do no?
Yeah. So how do our users get to their service instances? So now we have all this infrastructure as code and configuration as code, but how do we actually provide this to our users? And our approach to it is to provide a self-service application to our users. It's a web application that can be used simply with a browser. So the users go there and do the order of a new service instance via the browser. And the web application makes sure that we ask for all the required information for the initial setup. And this basically means we have no manual interaction for us. But what about our users? Can we also provide automation for our users? And yes, we can. So the same self-service application also provides a RESTful web service. And our users can use it to order their services via an API. We use open standards, such as the Open API specification, and this enables the user to implement their own application, their own automation, and also enables integration into other services. So what happened in our environment is that some other teams use our services as building block of a bigger application even. And there were not much interaction with these other teams because they just could use the API and the documentation. And that was super smooth to integrate with our services. So now we achieved no manual interaction, not only for us, but also for our users. And there's not a single click needed if you use the APIs. All right, let's go finally to the suffer part. So how much did we all suffer while implementing this? And what are the downsides from the user perspective? And what we need to mention here is there's a steeper learning curve. So even if the user is familiar with the application we provide, with the service we provide, they also need to learn our configuration as code approach. And this will take a while in the beginning, but long term, we believe it makes it much easier as you can track down changes much more easily, hand it over to colleagues and so on. So initially it will take longer, but long time we believe it totally makes sense. A second downside is that many applications, many services provide a web UI to offer configuration. And with our configuration as code approach, it's usually a one-way thing. So if changes are done through a UI, they will be eventually resetted by our configuration as code implementation. So these UIs that might be, depending on the application, quite nice to configure an application, cannot be used anymore. And last but not least, some limitations might become blockers, meaning that we might not be able to support all the features of an application through configuration as code. But if this is exactly the feature that the user is waiting for, it might be really a blocker. And yeah, this can only be solved by really focusing on the user needs and implementing as much as possible through configuration as code. All right, now let's look at the downsides from the provider perspective. So also for us, this whole approach means we have an increased time to market. We are not only providing the service as it is, but we need to look at how we can integrate configuration as code to our services. So it will take a bit longer in the beginning. Then we have higher training and documentation efforts, because this configuration as code approach is not something that users could look up in the internet or find even trainings for. We need to provide these trainings and the documentation for it. Updates of the services get more expensive. This is because we need to check if there's breaking changes that would break our configuration as code approach. So we need to have additional tests once we want to release new updates for a particular service. And sometimes fast fixes are needed. So even with all this infrastructure as code, configuration as code, self-service portal, sometimes things break and you need to just go the ops way, log into some system and fix the user's need. So this also still happens.
Okay, but there are not only downsides, Thilo. So how can one benefit from using it, and what do we recommend?
Yeah, of course, there are benefits, because if not, we wouldn't have done it. So what do we get by using infrastructure and configuration as code? So the services get traceable. And this is quite an important part. So changes in configuration are can be seen by anyone, because we have version control, and it's clear where the configuration can be found. So this makes it understandable. So it's not, the configuration of a service is not hidden behind some web interface or some obscure configuration files that might be on some file system that you usually don't touch, but it's explicitly in version control at a defined place. The service gets also reproducible. So we can very easily get to a specific state of the service. And we can recreate the state at any time. So this has multiple advantages. So we can roll back super easily. If the configuration somehow breaks the service, we just roll back to the previous version. And we can also achieve to move a service from, let's say, on-premise location to a cloud region, because we can just reproduce the exact same state in the new location. And this makes the service also maintainable. So changes are easy because you can always roll back or adjust it. And this offers team collaboration for the management of an application. It's not like you have this one guy that needs to take care of the instance. It's really, it can be handled as a team collaboration, because there is a common interface and one place in version control where you do it. And last but not least, it makes the service scalable. So we can apply this approach to manage large infrastructure.
Okay, Thilo, so which tools do we recommend when working on this, when we want to now implement it?
Yeah, so the standard answer to this is it depends. And it depends on multiple factors. So first of all, it depends on the team knowledge. So what tools are you familiar with? Where do you have experience in? Then it depends on your existing infrastructure and maybe the existing tools available in your environment. And it also heavily depends on the service you want to provide. So different services might have different restrictions, or you need to use different approaches. So it highly depends on the service. In our particular use case, we made use of various tools over time. And if you remember, we provide several applications to our users and with dedicated instances. And for the infrastructure part, we used, especially in the beginning, a lot of Ansible. That is coming from the era where we targeting mostly on-premise locations and we're not yet in the cloud. Later, when we targeted AWS and Azure, we moved on with Terraform for the infrastructure part. For the container orchestration, we were using OpenShift because that was the platform that was available in our company. Over time, a Kubernetes service got introduced in the cloud. So we moved to a plain Kubernetes solution and we're using or are using Helm for the container orchestration. For the automation part, we have Jenkins history, I would say. So we put a lot of automation into Jenkins, but also this changed over time. So with more experience in the team, we moved on and got rid of many of the automation parts in Jenkins and recreated it in Shell or Python scripts that were especially designed for our purposes.
Okay. So how do we, what are the best practices for managing large infrastructure? And one of the main key here is listen to the developers, listen to your users. And what we do is always we plan and we expect, but we do not over-engineer. So for managing large infrastructure, it's always the best approach to automate whatever is requested often before it gets requested too often. This means automate the infrastructure, the configuration, have automated tests for sure as well. So you want to make sure that it's actually working as you expect it to be. But that's always the hardest part. So what do we expect to be requested? What do we expect to be needed? And yeah, is it then actually needed or not? Or is it just over-engineered here? And this leads us to the next one, listen to your users.
Yeah. So our approach is to enable users to help themselves. And we mentioned already our self-service application. So we provide a way that users can really order or manage your services on their own. And the second part is enable customizations. In many cases, it's not enough to just provide a service, but the users need some customization to fit their specific use cases. And this can be achieved with configuration as code, wherever reasonable. There are limits and you need to find a balance. But for the core configuration, use configuration as code. And last but not least, document how the users can actually use your service. That's quite important because they need to know where to go, where to order, how to configure your service. So put efforts into your documentation. And also provide the best possible support. And what was very helpful for us is that we answer support tickets public, meaning public for our company, of course. But what we have seen is that other users, other teams can see common answers to problems or questions, and this will really reduce your total support efforts. And we even sometimes have the cases that other users answer support tickets for us. That is really nice. Also, we treat support tickets as valuable information bases. So if we see that some questions or some problems repeat many times, this is usually indicates that something needs to improve with your service, that you're missing maybe some automation, some self-service, or have some other problems. Okay.
So Thilo, would we do it again?
The last question.
Yeah. So it will not work on my service, right? Well, it depends. But we say it can be applied for dedicated instances, for multi-tenant instances, meaning one is like one instance per team, one instance per request, or just one shared instance. And it can also be applied for self-hosted cloud services. So from our perspective, there are quite less limitations when it can be applied. So to ask the question again, Thilo, will we do it again?
And the answer is yes, with configuration as code deployed through infrastructure as code in a public cloud.
So that's it. Thank you very much.
Many thanks.
We are open for questions.
Thank you very much for these exciting insights to what you learned over the last years with large-scale infrastructure. We have a few questions from the audience, and I would briefly read them to you. So first of all, how about putting infrastructure as code and configuration as code in a mono repo? So probably in the same repository.
Yeah, I would like to take that. So it doesn't matter. One can implement everything in a mono repo. I guess the question is the same whether you're implementing microservices with 100 microservices with 100 repositories or with one. It's always the same discussion, and that's an individual decision to make. And I would say it's possible.
All right. Then the next question. How do you test all the different custom configuration settings from all your customers in case of a software update? Do you know all those settings, options? Can you test all combinations, and can customers reject any updates?
That's a good question. I will take the first one, the first part of it. So we implemented a testing. I scheduled a talk already for a regular tech day. Did not manage to make it for today, but yeah, it's a very interesting topic. So the idea is you have the container, you build the image, and then you want to ensure that it's still the test cases need to provide some valuable information that it still works, what you expect to be configurable. So what we do is we have some different configuration settings. We apply them to the image. Then we start up the application. We test if it's actually configured there. So we either open the UI or open API calls, check if it's the same, and then only then we check the image as latest and say it is there. But still, we might not cover all the different configuration options. And this leads us to the second part of the question. So Thilo, can one opt out?
So users have the option to not get automatic updates and do their own testing maybe on a dev instance before updating their production instance. And maybe also adding what we have blend here to cover more individual configurations in our testing is that we want to open test cases for our users so that users can basically supply their own test cases that get run automatically with our test infrastructure before we release new updates. And this would be then like a shared responsibility. The users support their specific test cases to make sure that their changes won't get somehow messed up, and we make sure that it's run before we release new updates.
All right, thank you. Unfortunately, we are out of time already. So maybe the last questions will be answered via Slack.
Yes.
Thank you very much for the talk, and see you in the rest of the conference later.
Thank you.